Hey everyone. Okay, so I made this video and then I lost the video, so here we go for me, round 2. Alright, so this is the last portion of the inequalities but with absolute value. So we've got 4 examples. The first example is the absolute value of 4x minus 3 is strictly less than 5. So again, pause the video, try it yourself, and then press play when you're ready. So this is an and, right, because it's the less than, which we figured out from the video before. Oh, also in the video before, I forgot to say that the answer for less than, this is an and. So then the solution are all values between negative k and k, so you have the interval. And then for the greater than, which is the union, means we have to have all the solutions shaded over here and all the solutions shaded over here. So then we have the interval from negative infinity to negative k, union k to infinity, right? The interval representation of the graph. And again, remember this is like A to B union C to D, or x1 to x2 union x3 to x4. All right, back to here. So since we have the absolute value alone, right, it's isolated, what do we do to drop the bars? We take the negative and positive of the outside. So I've got negative 5 is less than 4x minus 3, which is less than 5. Now we are just unraveling so that we get x by itself, right? The whole socks and shoes and then shoe and sock. So now we add 3 to both sides. So negative 5 plus 3 is negative 2, is less than 4x, which is less than 8 because that's 5 plus 3. And then divide both sides by 2. So we get x is greater than negative 1/2, but less than 2. So we draw the graph, slap down negative 1/2, slap down 2. The simple inequality says x is greater than. This simple inequality says that x is less than. So now your solution, right, since this is the overlap, is from negative 1/2 to 2. All right. So now over here, we've got the or, right, the greater than. Again, we're already isolated, so to drop the bars, we're going to take the negative and positive of 1, oops, which I did here. Then we're going to multiply both sides by 2. But do we need to flip the sign in this case? No, because it's positive, right? That's only if it's negative. So then we get negative 2 is greater than x minus 3, which is greater than 2. Add 3 to both sides. So x is between 1 and 5. So now, graphing, right, we have our 1, our 5, shade to the left because we have that x is less than 1. And then at 5, we shade to the right because we have that x is greater than 5. All right, and there you go. So then the interval solutions to this, negative infinity to 1, union 5 to infinity. All right, cool. So now the next two, actually the next 4 really are more about the definition of any absolute value and inequalities compared to a computational, I'd say. So here with this one, there's no real work that's involved. We just have to think about what it means to be an absolute value. So remember, absolute value measures what? Distance. Right? Absolute value defines distance. So this says that a distance is less than negative 4. But can we be less than a negative number? No, right? Because we can be at minimum 0 away from something, right? So here, this will always spit out either 0 if we're at the location or a positive. So what do you think the answer is? Yeah, it's no solution. Right? No solution, because I'll never be less than a negative value away from something. At minimum, we are 0. So remember how we describe no solution is either the empty braces or that kind of circle with a line through it to represent an empty set. So over here, the absolute value of x plus 2 is greater than or equal to negative 4. Here we've got, we're not going to be, so greater than or equal to, sorry, I'm all over the place. Greater than or equal to. So we're going to ignore the equal to part, right? Because as we just discussed over here, we can never equal a negative. At minimum, we can be 0. Since it's an or, we can just look at the greater than, right? Because that's an option, right? If someone says, do you want steak or chicken? Typically you only say you one or the other, not both. So greater than or equal to, we're just going to look at the greater than. So here, the absolute value of x plus 2 is greater than negative 4. Like we talked about over here, absolute value at minimum is 0 or a positive number. So now we compare. Is 0 greater than negative 4? Yep, checks out. Is a positive number greater than negative 4? Yep, checks out. So then the answer is all real numbers, because no matter what x is, we're always going to be greater than negative 4, even if x is negative 2 and we get 0. Even if x is negative 100. Well, negative 100 plus 2 is negative 98. But remember, since it's the absolute value of negative 98, it translates into a positive 98. Because remember, I want you to think of negative 98 as just 98 units to the left of something, not as in like negative $98 in your bank account type of thing, right? Okay, so these next two kind of capture the 0 option, right? Because I've been saying over and over again, at minimum, absolute value spits out 0 and then a positive. So these two examples were, okay, what if we're set to a negative? And these two are, okay, what about the case if we're set to 0? Well, here we've got the less than or equal to. So same thing like over here. We ignore the less than because it's the or statement. So we're just only going to evaluate if we're equal to 0. Because it says the absolute value of x plus 5 is less than or equal to 0. So we don't worry about the less than because not going to happen. So we just set it equal to 0. 0 doesn't have a negative or positive connotation, so we can drop the bars automatically. Subtract 5, so x equals negative 5. So the only answer is negative 5. So the only answer to this question, the values of x where the absolute value of x plus 5 is less than or equal to 0, is only at negative 5, because that's where I'm going to get 0. Otherwise, the statement's not true. Hopefully that makes sense. Again, if you have any questions, email me ld1168. All right, so now let's tackle the greater than or equal to. Oops, excuse me, we're over here, pardon me. We're going to tackle the greater than the absolute value of x minus 5 is greater than 0. So this is the greater than. We know that, right, at minimum this is 0, otherwise it's going to spit out a positive. We recognize that we're always going to be greater than 0 unless we are 0. So kind of the flip side, the reverse of this coin, is that we say, okay, if the only number we don't want is where we're equal to 0, we're going to do a similar thing that we did over here. So again, okay, only number we do not want is what will make us equal 0. So we set x minus 5 equal to 0, add the 5 over, get that x equals 5. Remember, this is the only number we don't want, so it's all values of x such that x does not equal 5, or negative infinity to 5, union 5 to infinity. Right? Again, because all numbers are going to be greater than 0, because remember, absolute value spits out a positive, or it spits out 0. So positive 5 plus 5 equals 0. We want strictly greater than, so this is the only number we don't want.